In this question, we have an object that is moving along three separate segments of its motion. And the question, of course, describes those three segments right here. We've drawn a picture that represents that information. So, for example, in segment 1, the question notes that the object will start from rest. Because it's starting from rest, we have noted that the initial velocity during that segment is 0 meters per second. The object has a constant acceleration of 2.77 meters per second squared, so we've labeled that as well, and it travels for 15 seconds. In the second segment, note that the question says the object is moving with a constant velocity. Now, of course, if the object is moving at a constant velocity, then the acceleration is actually 0 meters per second squared. Also note that the time interval for that segment is given in terms of minutes. It's 2.05 minutes. So we'll have to take a moment here and convert that into seconds. Now, of course, we know that 1 minute is 60 seconds. So we'll have to multiply by that conversion factor. Doing so will cancel out the minutes, and 2.05 times 60 is 123 seconds. So we'll make sure that we alter the time accordingly. And then in the third segment, it has a constant negative acceleration of negative 9.4 meters per second squared, so we've labeled that, and the time is given in the appropriate unit of seconds for that third segment. Now, it turns out that it's going to be useful for us to calculate the final velocity for phase 1 or segment 1 of this question. And if you look carefully, you have the initial velocity, the acceleration, and the time. And therefore, in order to calculate the final velocity, you would want to use this first equation of kinematics. So we can say the final velocity is equal to the initial plus the acceleration multiplied by time. So for the first segment, the initial velocity is 0, the acceleration is the 2.77 meters per second squared, and then multiplied by the 15 seconds. So when you work that out, you will end up with 41.55 as the final velocity. So why don't we actually note that right over here? It's 41.55 meters per second. Now, the next important thing to note is this. The final velocity of segment 1 becomes the initial velocity of segment 2. So we can say the initial velocity for segment 2 is the 41.55 meters per second. Also note that during segment 2, the acceleration was 0. Now what that means is the velocity isn't changing. So if the initial velocity of segment 2 is the 41.55 meters per second, then the final velocity of segment 2 will also be 41.55 meters per second. And again, that's because the acceleration is 0, and therefore the velocity isn't changing during segment 2. In segment 3, we apply that idea that the final velocity from segment 2 becomes the initial velocity of segment 3. So we'll note that the initial velocity of segment 3 is the 41.55 meters per second. Now, with all that preliminary work accomplished, we are ready to calculate part A. It wants the total displacement for the trip. Now, this object is moving in a straight line. We don't have to worry about any sort of strange vector concepts here. We can simply apply the displacement equation, and what we'll do is apply it 3 times. We'll do it for each of the 3 segments, and then simply add them all together. So we'll come down below and do so. Why don't we write down the equation one more time for reference. So the displacement is equal to the initial velocity times time plus 1/2 acceleration times time squared. And again, the total displacement, maybe we can write this as delta x total, is going to equal the delta x for phase 1 plus the delta x for phase 2 plus the delta x for phase 3. So we're going to use all the information that we know. Why don't we rewrite this equation just one more time? And for each of these delta x's, we're going to fill in this expression right here. And what we've done is we've encapsulated each delta x expression in parentheses. That way we can visualize the values for segment 1, segment 2, and segment 3. So what we'll do now is we'll plug in all of the known values that we have listed for each of the 3 segments. So we've plugged in all the known values of each of the 3 segments. Again, you might want to just make sure that all those numbers were plugged in the same spots you would have plugged them in. We omitted the units for clarity. Now the first set of values comes out to 311.625 meters the second set of values comes out to 5,110.65 meters, and the third set of values is 91.15 meters. And we will actually use those individual displacements later on in the question. Once we add these all together, we get 5,513 meters. So this would be the correct answer, finally, to part A of the question. We'll move on to the other part, B, which wants us to get the average speeds for all three legs of the journey. We'll come down here and calculate those. Now, the average speed for segment 1 would be the distance traveled in segment 1 divided by the time of segment 1. And so the distance traveled in segment 1 was the 311.625 meters, and the time for segment 1 was the 15 seconds. So we can plug this set of values in, and when we do so, we're going to get about 20.8 meters per second. Then the same idea for segment 2. We'll plug in the distance traveled in segment 2 divided by the time for segment 2. The distance traveled in segment 2 is listed right there. The time was 123 seconds. And so we end up with about 41.6 meters per second. And finally, the average speed for segment 3 is the distance traveled in segment 3 divided by the time for segment 3. The distance traveled was listed as 91.15 meters, and then divide that by the time, which was 4.39 seconds. And we work that out, and we end up with about 20.8 meters per second. And then we needed, to finish off the question, the total trips average speed. Okay, so for that, for the total trips average speed, we're going to have to add the distance traveled for each segment, and then divide that by the total time. So T1 plus T2 plus T3. We already had the total distance. That was the 55.13 meters. And then divide this by the total time. So you just add up the 15 seconds plus the 123 seconds and plus the 4.39 seconds. So punching that all in will give us the following value of 38.7 meters per second. So that would give us the average velocity for the entire trip. And then up here we have the individual average velocities for each segment of the trip.